Okay, sorry for being late. Today's session is Machine Learning Dev Dojo. And we were given 2 hours and a half. And I'm the facilitator, Shido, from the machine learning team. Okay. Now let's look at the lecture overview. I'm going to talk about what is machine learning. And also when we use machine learning in our day-to-day work, how we do that, and also it doesn't include payment part, but how we use machine learning in the marketplace of Mercari. And then after that, we're going to do the hands-on for 90 minutes. Okay, let's move on to the lecture. Key ideas. Recently, again, it's maybe the third or fourth machine learning boom. You often hear AI, machine learning, and deep learning in the past. So this is the overall picture of these 3 concepts. So what is AI? It is the acronym of the artificial intelligence. So when human feels that, oh, this machine or something has the intelligence, then that's an artificial intelligence. The very simple source code could be AI, one form of AIs. And in order to achieve the usage of AI, one of the approach is machine learning. So we have non-machine learning, which is called the rule-based method or the statistical method. Machine learning is that we prepare a lot of data first and they make machine to learn automatically. So that scheme is called machine learning. And the one way of doing the machine learning is deep learning. Deep learning has a lot of the machine learnings. There are some like a diffusion model and the other new words. So that is part of deep learning or one of the approach. So in a nutshell, so only the small part of the AI is becoming a hot topic. But when it comes to AI, then sometimes people talk about the deep learning, but actually they're talking about AI. And yeah, so this is how we can put in the pictures. So let's talk about machine learning. 99% or 95% of the machine learning models are described like this. You see the formula, and you might think like, oh, it's too difficult. But let's go one by one. Let's go through one by one. Yeah, just stay with me. Be patient. So X means input. Why? When you input X, what's the outcome or expected outcome is regarded as Y, and X and Y together is called data set. And theta, F is an index and the theta is a parameter. This is the machine part. So we have to make this machine to learn. So that's the machine learning. And when we make the machine to learn, then we use loss loss function. So we want to make loss function as minimum as possible. And there is G. And this is a regularization terms. We have to be creative so that the machine can learn properly. So in Mercari, when we apply this to the projects in the company, X could be, if we put the data set of the product's information, if you want to create a machine learning to come up with the appropriate price point, the X could be the name of the product or the category or the specific brand. So any like a product information could be X, and Y, you want the outcome, which is a price in this scenario. And F, there are many different ways. There are the most simple ones to the most complicated ones. So there are various ways of approach. And loss, the actual price and the machine learning output price, we want to make it as close as possible. So the mean squared error, are you with me? Okay, next. So machine learning and data. The most important thing for machine learning is how to handle data. That's what I believe. So there are many machine learning projects. So as I said, that we have to define X, Y, and loss. So that's the most important part. And then we have to make the machine to learn, but that part can be done by anyone or everyone can do. So designing X, Y, and loss is the most important things. But for the hands-on session, we already predefined the X, Y, and loss for you. Anyway, my point is, if you want to make a project to come up with the price of the particular product, what are the information that you can use of? What will be the beneficial information or data set? So among those data, how can we eliminate or remove the unnecessary data? There are some like exclusive listings, and sometimes there are some like a bundle products after the multiple discount negotiation. So, and how much data we should prepare, and what is the level of the accuracy in order to make a business impact. So that part will be important.
Yes, so moving on. So for those who didn't learn machine learning in college level, I would like to go through this part. So the common patterns is something that I would like to talk about on this slide. So there are three mainly. So from the top here, I think 90% of the machine learning can be applied to one of these three models. So first is supervised learning. So the equation above, in where X and Y is known. So the variables and the data is known. And based on that, we train the machine learning model. So that is supervised learning. And second point here is unsupervised learning. So simply put, this is where the Y variable is not known. So for example, you want to make the data abstract, but there's no variable known. For example, maybe recently you don't really hear about this, but like for example, Word2Vec or Chat GPT, making it a pre-training, that will be unsupervised learning. So training the model without target variables. And the next point here is reinforcement learning. So this is where the Y variable will only be known once it is being executed. So we input the X variable here in the model, and then they'll suggest that, okay, maybe this will be good. But in order to know for real if the action is good or not, we need to take the action. So you need to try it out to see how much the reward is. And then based on that, we update the model. So this is one of the learning pattern. Like for example, in the home screen layout optimization, for example, we have this bandit algorithm that we have. All other companies, they use AlphaGo for auto-driving system simulation. So those are some examples. And usually we have these 3 common ML patterns. This covers about 90% of the models out there. And within that, 80% of it is usually supervised learning. I think you can safely assume that. So supervised learning. So if you further break it down, there are regression and classification. So for regression, the Y variable or the answer, for example, item price, it's a static number. So we try to gear towards this specific number. The next one is called classification. So normally it's categorical, or it's a category. Okay, I'm going to go through real quick. So how do machines learn? I might skip some parts, but so as you can see from the diagram just now, I wrote here minimize loss. So when you place the X variable, we look at the output and look at the actual Y variable, and we calculate the loss. So we want to minimize this loss. It's a bit difficult to see. So if you can look at this slide here. So for example, in the machine learning model, we have Y equals WX plus B. This is the linear regression. So let's use this as an example. So we have data set X and Y, and what we want to learn is W and B only. So how do we learn the W and B variable? We differentiate it. So the model output WX plus B minus Y, this is the difference, and you make it to the power of 2. And then you divide it by W and B. So we differentiate this and we get this equation. And similar, if you differentiate with B here, you will get this equation. So I think you might have done this in high school, but the differentiation will show the gradient. And then you can get what's the gradient like. And what's the good part about this is that the W and B you will be able to put it in graph form like this. And the gradient here shows the loss, and the red dot here shows the point of W and B where the machine learning model is at. Like for example, this first part here, after you differentiate, let's say you want to make the gradient in the down in this way, then you can move the W this way and you can move B this way. So by differentiating, you will be you know which direction to go. And then once you get the gradient after differentiating, you will be able to know what kind of variable to place for W and B respectively. And in most of the machine learning models, we train the models this way. It might be a bit difficult, but hopefully you can understand the concept. So just now I said y equals wx plus b. So this is one linear regression. This is a linear model. But let's say, what if it's not linear? Like, what if there's a curve here? We will use a nonlinear model. Like, for example, y equals wx to the power of 2 plus ex, etc., etc. So if there's like a power of 2, it becomes not nonlinear. I mean, of course, there are a lot of complicated equations. We use a lot of those models in those cases. And if it's a nonlinear model, you'll be able to train the model, but there's a lot of components that you have to take into consideration. And I'll go through that later on. So the one to the second to the left is a linear model. We can only categorize it this way. But if it's non-linear model, well, you'll be able to see that we can categorize the data sets this way. So if it's non-linear model, what should we be cautious of? You might be wondering. So as written at the top here, it's very important to be able to generalize. For example, if the data looks something like this, distribution looks something like this, and if you try to separate it completely from the red to the blue, it will look something like this in the green line here. But in the actual data, there are some noise, there are some discrepancies. And if you use the green line here, if you try to use this green line here, then it's very difficult to split it. For example, let's say if you add in additional red dots or blue dots, it doesn't support those dots anymore. Let's say if it's actually blue, but it's deemed as red, for example, if we use this green line. So what we are trying to say is that even if there's some variance or discrepancy, we want to try to aim to have the line which is in black color here. So how do we make sure that how to split the data, for example? So for example, you can split data into 2 or 3, and then within that data, we train the model using one data set, and then we can cross-check using the other data set. That's one method. So moving on. And also, there are a lot of trade-offs. And what are some of the trade-offs are that the speed and the accuracy. So when you think about models, you might think that a bigger or a more complicated model is better. And for Mercari, we have thousands of requests incoming. And let's say if you spend 1 second, so let's say there's 1,000 requests, and we have to have 1,000 computing resource to process those requests. So if you have a model that only takes 10 milliseconds, then it can cut down the speed. So we want to make it as light as possible, but usually the tendency is that the accuracy will also be lower. So it really depends on the project, really, on how we strike the balance. Like for example, for a certain project, we want this much accuracy, but it costs this much. But we want this model. So we always have this kind of discussion every time. And every time you discuss, whenever the requests come, it's going to be very slow. So every day or every 1 hour, for example, sometimes we take the approach of using batch jobs for high performance. And also in terms of cost, not just computing resource cost, but also maintenance cost is something we need to consider. Like for big models, especially, maintenance is very difficult. Maintaining a trained model is difficult, and also knowing how this model is being trained and sharing that knowledge to an engineer, for example, 2 to 3 years from now, that's also very difficult. So in the sense, it's a kind of engineering cost incurred. So that's also something that has to be discussed along the way.
Okay. Reprocessing. So basically, this one I created for hands-on. But anyway, it's very rare that we can just directly input the data for the machine learning. Usually we need the pre-processing. So to be more specifically, we talk about the loss. In order to calculate loss, for instance, for the category ID data, category ID data is with numbers. So the 1 and 2 difference is only 1, but 1 doesn't have any meaning because it's just an ID, right? So in case of Monday and Wednesday, I'm not sure if the best example, but so this is a one-hot encoding. So the dates of the week, day of the week, there are like we prepared the 7 row of the numbers. And for Monday, we put a 0, 1. So Wednesday we can describe like this on the screen so that we can eliminate using like a 2 or 3 different numbers because it doesn't have any specific meanings between the 1 and more numbers. So it's difficult to put like those kind of raw information into the machine learning. So we can prepare the specific order or the row of the numbers. And then we can change the text into numbers so that those kind of natural data can be transferred for the machine learning. So we do like various things, but those are just some examples. Okay, we are running out of time, so let me skip some of the slides. Okay, let's look at what are the considerations or what we have to pay attention for building machine learning applications. I was hired as a machine learning engineer, so I shouldn't say this, but there are some benefit for machine learning, but there are non-benefit as well. So there are strengths and the weakness as well. So we cannot just use machine learning for everything. So what the machine learning is good at are the followings. If some project require a lot of human effort, then that's the good case where we can apply machine learning. For instance, the customers are human beings, so the mimic what the human is doing. So for Mercari case, the customer support agents are humans, but that we can ask the machine learning, we can use the machine learning so that they can mimic how the customer service agents do. So that is something the machine learning is good at. And also for the collective intelligence. If we creating the data only for machine learning is not a good idea at all. So for instance, based on the product information, item information, and make a guess of the price point. So those example, why it worked well is because customers input all the data, including the picture of the product and also the price point and so on. So based on that information input by customers, that we could make the best of use of that. But if we have to create the data by ourselves, inputting everything, and then that's difficult. So yep, so that's something the machine learning is good at. What machine learning is not good at, it requires high cost. For the implementation, yes, it cost. And also for operating, it requires a lot of computer resources. It's costly. And also, machine learning require a lot of maintenance to keep a good quality. And that's also troublesome as well. The more data, the better, but it's very close to what I said in the beginning. Sometimes we have to clean up the data, and then we have to avoid the overfitting and also the concept drift. After training the machines, sometimes law and regulation can be changed, or the hot topics or hot products are changed. Then that is a case of the concept drift, changing the trends in data. So yeah, so that's something we have to take into the consideration too. Now, if there is a one machine learning project, what we have to take into the considerations. So this is the visualized version. It's one of the famous ones. So training machine learning is here, only here. Rest of them are outside of the machine learning, but those are the must-do things. So the machine learning engineers are responsible for all of these items, not only training the models. So that's a misunderstanding. We do other things as well. And that's the majority. So we have to do the configuration. X, Y definitions, how we should set up and how we should configure it, and what level of the accuracy can give us the business impact. So that kind of investigation and the verification. And then we have to collect data set. And then we have to do the pre-processing. We have to make some adjustment so that we can feed the data into machine. We also need to look at the data verification. As necessary, we have to remove some of the unnecessary data. So now the data is ready, so let's use the machine learning. After machine learning, in order to release that into the production environment, we need a machine resource management. And if you do some experiment or the monitoring, so I think case when we do experiment with using the model and release this feature in the production environment, we have to do the analysis of the business impact, business metrics. So whatever the way of the approach of the deployment, for the vector search, we have to make some preparations. So yeah, the various things we have to do after the machine learning. And once it starts functioning, we have to always monitor if the accuracy is still maintained. So sometimes we create the tools for the monitoring and also involve in the actual monitoring tasks. And sometimes we write or set the notification system. So if we were to use machine learning, other than the training the model, there are so many things that we have to do. Okay. Let's talk about Mercari business. So looking at Mercari data set, we have a lot of high volume of data. When we look at only the listed data, as of 2022, more than 3 billion items data we have. All of them have picture of the item and the text descriptions and the category IDs and so on, and the price point. It's very rare for the company to own this much volume of data. So those are the list of the data, the price point, the title, name of the categories, and also user the behavior logs is another one. So the who bought what, who searched with what word, who clicked, and how many people look at the description and how many people liked. So those are the all data set, and we have the history and the record of those data. So using those data set at Mercari JP, what we are doing. So those are the topics I'm going to talk about. When we run A/B test, sometimes we decide not to use the feature, and then we remove some of the data. So because we keep adding and removing some of the information, so maybe this information, this slide is not up to date. So just that's a disclaimer. So briefly, so what kind of projects we had in the past? Let's look at this quickly.
So for first is about the home recommendation. So at Mercari, we do not have the catalog. I mean, we do have, but not all the items are linked to the catalog. Like for example, we do not have a catalog that covers all of the items that are being listed. And usually the item is just one stock only. So in other words, if someone buys it, then other people cannot buy it anymore. So that's the difference between other EC sites. So handling this is the biggest challenge. So that's the biggest challenge. So when we do the home recommendation, how we do this is first we create this concept called topic. So first we label the products with the topic. It's kind of similar to category, but for example, it's a golf related item, and it's the brand is Mizuno, for example. I have the various different topics. Then we will say, okay, this item is this topic, and okay, for this other item, this is the topic and another topic. So we label different topics to the item. And this is automatically generated. The topic is automatically generated. And also, after we do that, we'll be able to see which topics will be the best for the particular user. So when you look at the topic, like for example, we can use a search filtering condition. So based on the topic, we assign the topic, and then we apply the recommendation algorithm. So that's the general approach that we take. So the UI is completely different now, but on the home screen, you'll be recommended these items based on what you have viewed. So I think this consists of the most of the home screen. So topics that might be of interest to the customers or users will be shown. We will show the items, different items, etc., etc. So the components shown on the home screen, actually there are a lot of different components. For example, the campaign information and also not just recommended items, but viewed items, liked items. There's a lot of information that we can show. So it depends on the customers what will work the best. So we look at the past action that the user did to determine which component to show. And that's how we optimize our process. So this is called SERP. It's a search engine result page. So the item ranking is also being re-ranked. So when we get the item, we use Elasticsearch. But after that, when we re-rank the item, we use machine learning for that. We have this blog here, blog article here. So if you are interested, please take a look at this article. And we have AI listing. So when you take a photo of the item, then the item title will be written here. And when you take a photo of the item, and let's say if the item has a barcode, we also show the barcode on the screen. We use machine learning for this too. Not too sure if it's still working. It looks something like that. You take a photo of the keyboard and something like this. The title and the category will be filled in. And also about how it works, CRE as well as TNS. So composition between customers. Please read through this paper here. So there are some action that we forbid. Like for example, canceling the transaction and communicating even after that, then the handling fees won't be incurred. So this is not acceptable. Also, threatening communication is also forbidden. You cannot send those messages. But there are some customers who still do it. And in the past, CS members have done this manually, but we implement machine learning now. And if there's some suspicious activities, then we automatically report to the CS member. So when we did this manually, we look at it 100 of messages, and we only managed to pick up a few, and we search by keywords back then. But when we do that, the accuracy is very low. But by implementing machine learning, we were able to improve this significantly. And also about inquiries. So the one just now, it's not the transaction messages, but more of the, not just the transaction message, but also items that you list, and in the description, if there's some keywords we can also apply this. And also about inquiries, customer inquiries. We also have machine learning in place. So right now, I think the UI is like a chat. So when you make an inquiry, CS will respond. But what happens in the background is when you send the inquiry, we do this routing algorithm to send the inquiry to a particular CS agent that's very familiar with a certain topic, for example. So we delegate the message to the CS agent using this routing algorithm. By doing so, the response time can be significantly reduced. Workload or the burden on CS will be reduced as well.